Welcome back. Now it's time for us to do a proper t-test. In the last little video we saw that when we ran a test for variances, that the variances were equal between the male data and the female data. And so that allows us then to do a t-test assuming equal variances. Alright, because we have the opportunity to do a t-test for equal or unequal variances, we had to do the F first. So that's been done. We know the variances are equal. Let's go ahead. So we go to the Data tab and to Data Analysis, as we always do. And this is all alphabetical, so the t-tests are at the bottom. Again, we know that the variances are equal in this particular case, so we're going to do the t-test for equal variances. Say OK. And it's the same sort of setup every time, regardless of the test you're doing. It needs to know where the data are. So I'm clicking in the box and saying, okay, the male data are here. Clicking in the box, the female data are there. It's a lot easier if you arrange your data in columns in Excel. Don't worry about the hypothesized mean difference. We'll not worry about that. It will actually return that to us, so we don't have to hypothesize anything. We do want to click labels. That indicates that these words males and females are the first entry, the first row of each column, so it knows that it's not a number it should consider. Again, the golden rule in statistics, alpha 0.05, we never want to change that. We do want to click in the box for output range and give it a place on the page to put this, because it puts out a fair amount of data. And say OK. All right. Let's go ahead and blow this one up and see what we've got here. So we got a lot of data. We'll see what it says. Most of it you don't have to worry about. It does give you the means. So the means are 107 to 99. Is that statistically different is the question here, given these variances, the number of observations, and so forth. And we have two p-values in this, a one-tailed p-value and a two-tailed p-value. And I don't have time in these little 5-minute videos to go into all of that, but unless you have reason to believe that males would always be higher than females, that they could never be below, say, or females always higher than males, you would not pick the one-tail, okay? So don't do that one unless you have reason to believe that it has to be the difference has to be in one direction. If you're saying that, look, all I can say is that there's probably, or there may be a difference, males may be higher, females, I don't care, then you want to do a two-tail, okay? And there's a long explanation there, but again, we don't have time for that. But in this case, we would want to do a two-tailed t-test. And so again, the computer is returning to us a probability value, a p, of 0.23, 23% roughly, that the means are the same, okay? Because we asked it to do a t-test on the means, and remember, a p of less than or equal to 0.05 is the golden rule in stats. And we can see here that we've got a p-value of greater than 0.05. When it's greater than 0.05, we conclude that they are not different. So in this particular case, males and females, going back to our data over here, they do not differ statistically at the 0.05 level. Therefore, if we wanted to, we could pull all that data together. So that's, in a nutshell, a t-test. So I have another example here, whoops, for you to do. So this would be a good time to pause the video and actually see if you can go through and do this particular test. Go through the keystrokes and then see if you can interpret the output that it gives you. And I'll do another quick video to show the result of that.